A new age in medicine began on September 14, 1990. On that day, at 12:52 in the afternoon, a physician inserted a needle into the hand of a 4-year-old girl who had a fatal disease. Flowing through the needle was a precious liquid, carrying life-sustaining immune cells. What made these cells special was that 2 weeks earlier, they had been removed from the young patient, grown in the laboratory, and then genetically modified to correct an error in their DNA. The experiment was a historic moment for science. In the first human gene therapy experiment, the goal was to genetically correct particular cells called T cells. These immune cells are part of an intricate, well-orchestrated defense system that protects the body against harmful intruders and fights infection. In the procedure, mature T cells were removed from the patient and grown in the laboratory. They were then infected with harmless genetically engineered viruses carrying a normal gene for the enzyme adenosine deaminase. The viruses then incorporated their DNA into the DNA of the patient's cells, repairing rather than destroying them. The genetically corrected T cells were then returned to the patient. Although not all of the cells received the new gene, enough were affected to produce a therapeutic response.
Retroviruses are a family of viruses that include HIV. They have an RNA genome, which they convert to DNA inside the host. This is the opposite to the usual flow of genetic information, hence retrovirus. The viral DNA is inserted into host DNA, where it can either hijack the cell's own machinery to produce more copies of itself or lay dormant, even being passed down to future generations. In fact, almost 8% of the human genome is made up of truncated retroviral genomes that no longer code for the full virus. The pernicious nature of these viruses has ironically been hijacked by scientists to treat previously incurable genetic disorders by modifying the viral particles to deliver fully functioning human genes to patients that need them, effectively curing them of their disorder.